Hey everyone! So in this video, we're going to be taking a look at how to use the chain rule with some exponential functions. And specifically, we're going to be taking a look at exponential functions with base e. So first thing, just to remind ourselves of what the chain rule is, we use the chain rule with composite functions. So let's say we have a function capital F of x, and let's let this be the composite function f of g of x. And remember what this means is the function g of x is inside the function f. Our chain rule is going to give us the derivative of our composite function is equal to the derivative of the outside function times the derivative of the inside function. Or in Leibniz notation, if we let y be equal to f of u, and we let u be equal to g of x, what we end up with is the derivative of this is the derivative of the outside, the derivative of y with respect to u, times the derivative of the inside, so the derivative of u with respect to x. Now what we want to do is we're going to let one of these functions be the exponential function. And what we're going to see here is we end up with a little bit of a shortcut for the chain rule. So I'm just going to say that I have a function here where y is equal to e raised to some power. So in this case, my function f is the exponential function. And then inside that, I'm going to put in another function u. So written like this, my outside function is the exponential function e to some power. And my inside function is the exponent. In this case, it's u of x. So then the derivative of this, what we want is the derivative of the outside function, so the derivative of y with respect to u, and we'll multiply that by the derivative of the inside function, so the derivative of the exponent. Now, the derivative of the outside, the derivative of the exponential, we already know that that just stays the same. The derivative of e to the x is just itself. So this is still e to the ux. And then we're going to multiply this by the derivative of the exponent. So the shortcut with the chain rule, because the derivative of e to the x is itself, so what we end up with for the derivative of an exponential, it's equal to the original function times the derivative of the exponent. So to show you what I mean, let's take a look at a specific example. So I have y is equal to e to the x squared minus 4 power. So then my derivative, this is going to be equal to the original function. So I'm just going to repeat this because the derivative of e to something is itself. And then we're going to multiply this by the derivative of the exponent. And the derivative of the exponent, we can find that by using the power rule. So the derivative of x squared is 2x, and the derivative of negative 4 is just 0. So that's it. That's our derivative. And if I wanted to, I could rewrite this as 2x times e to the x squared minus 4 power. So again, the derivative of an exponential, what it ends up being is the original function times the derivative of the exponent.